Normally when you get a job, you have a boss. And really your goal is to keep the boss happy. There's nobody else necessary to keep happy in order to keep your job. As an engineer, it's quite mysterious who your boss is. Hopefully by now you've learned that your instructor knows very little about this project. Your instructor has not done the project before, has not fiddled with the materials or the devices that you have. They just have ideas. But then your instructor's ideas often are not good ideas, and you need to throw them away. So what's the role of the instructor in these? Basically, yourself there on the far right, the engineer, the student. In the middle, you have your instructor who's acting like a project manager, not as an engineer. And on the far left-hand side, you have people that are called stakeholders. These are people that are invested in the success of your project, but they're going to be invested in different ways. So you as the student engineer do all the work. Your instructor basically is watching what you're doing and reporting on what's going on to the client. So you don't have to. Clients they're like the sharks on Shark Tank. They're the people with the money. Clients are usually other engineers, and they have all sorts of ideas and opinions, but they don't have time to talk about them, and they don't want to be talking to you all the time. So they talk to the client, and they talk to your instructor, and the instructor doesn't talk to them all the time. I mean, the ideal relationship from a client's point of view is the client says, let this be done, and then it gets done. There's not back and forth and lots of questions. Client communication should be difficult 3 or 4 times a semester. Initial startup, progress report, final report. Now the client is the person that pays the college money or pays the engineering firm money and ultimately pays your salary. Some colleges get $40,000 per project team for a group of seniors. And the customer is a totally different animal. The customer is the person that's going to change their lives and use whatever device or whatever service that the engineer creates. And then there's senior engineers. Senior engineers have been there, done that, and don't have a lot of creativity, but have got a lot of advice and a lot of, watch out for this, watch out for that, watch out for that stuff. And so they can be good and they can be troublesome. So let's get specific. Here's a past project. It's called V-Linc. This is an organization out of Baltimore. It's pretty unique. People with physically challenged family members apply to V-Linc to have a bar made for their van so the wheelchair doesn't roll out the back when it stops. They have a $30,000 or $40,000 wheelchair and they have a bed. And those are the only 2 places these people live, is in the wheelchair and the bed. And they need something in between that gives them more control over their environment, that makes them feel alive. Last semester, the actual people at V-Linc were Lisa, Andy, Andrew, and Alice. This semester, they're paying Howard Community College up to $500 for this project. So our goal is to keep them happy and keep that money flowing. The customer this semester is a 9-year-old girl down in Silver Spring. Our goal is to keep them happy. Now, the instructor is the project manager. The instructor is wearing multiple hats, and this is what's confusing, because the instructor is pleading with you. Create tasks, fill out your work breakdown sheets. Tell me what's going on. Oh, here's an idea. I have an idea what you could be doing. But ultimately, the goal of you as a student is to keep the client happy. Write the documentation that keeps the money flowing to the community college and keeps the customer happy. Right? Delivers to Kevin, Mary, Larry, and Karen a device that works. So the instructor could be acting like a senior engineer at one point, saying, that's not going to work, try this. The instructor could be fronting for the client, saying, I believe the client thinks this. Please talk to me before you talk to the client. We want to try to minimize the number of times we talk to the client, so let's bundle them all up. It's sort of like you want to order material. Well, you can't order a $1 device, and a $5 device, and then a $300 device, and a $200 device, and create this mountain of paperwork for the community college. Everybody within the community college support staff will start complaining. We got to chunk things up. Same thing with communication. So the instructor is playing as a manager, a project manager, not really as an engineer. So here's another one. This is the current bacteria project. The client's Will Strobe. He's another professor here at Howard Community College. He's got a grant from the National Science Foundation and has money to spend on equipment. So we're trying to make this raft that goes out into the pond and collects water, and siphons it through some paper to pull out the bacteria so he can do a genetic study of the bacteria, count the bacteria. So the customers are going to be the students that are receiving STEM grants of $6,500 a year, and we need to keep them happy. We need to give them equipment to get out there in that pond. The plant ops is not going to let you go out there on a boat. So this is the third semester for this project. So this is an example of the stakeholders. Last semester we ran a brain project, and the client was not really specific. It's the National Academy of Engineering. They have this grand engineering challenge. So let's see, one of the challenges is the brain. Reverse engineer the brain. The school doesn't get any money from them, not directly, but this is again another potential grant. We could plug into this grant that the school already has and help justify that grant. Didn't get chosen for this semester, but maybe next semester. Now, out in the commercial world, as an engineer, you're going to be part of a supply chain, and most often your customer is an engineer and your client is an engineer. So let's say you're working right here as a manufacturer. There's going to be an engineer up here that has components you want and need. And there's going to be an engineer down here that's accepting the final product you manufacture and testing it and checking it to make sure it's okay. So most engineers work with other engineers within a supply chain. You don't see engineers down here that read in Walmart walking up and down the aisleways. You do see this in the safety data sheet process. The Occupational Safety and Health Administration starts up here with the raw materials and says, if you're going to produce gypsum, then you've got to have a safety data sheet associated with gypsum. Then the people that make wallboard get gypsum, smash it up, turn it into a chalk in between the paper of the wallboard, and then they have to produce a safety data sheet for the piece of wallboard that goes down to the manufacturer of a prefab home. I'm just making something up right here. So these SDS sheets get pushed down the supply chain, and they ultimately stop here at the customer. The customer doesn't really see them. The customer falls under a whole completely different set of consumer laws, and then customer protection laws. And then the recycling or the landfill, the cleanup, that's done by the Environmental Protection Agency. And so you'll see these stakeholders and knowledge of these stakeholders and knowledge of the whole big picture, the larger context of what you're participating in as an engineer. You'll see these in the ethic questions on the FE test. Here's the FE tests, the civil FE test. And right here is a section on, there's going to be between 4 and 6 questions. And the best way to study for these questions is to study the stakeholders according to the books that help you prepare for this test. So the larger picture of the stakeholders is this. The public ends up being the customer. The client is down here. So who are the public? Well, those are the people that ultimately spend money and purchase hang gliders. The next stakeholder down are the laws, the standards, the best practice. Okay, so what about hang gliders? Well, when they initially came out, people died. The hang gliders got together and said, look, we've got to self-police ourselves. We've got to come up with rules and procedures and training and stuff so people don't die. And they eventually got it down to the point where hang gliding became a pretty safe sport. The engineering profession. What does the public think of the engineering profession? What are the reputations of all those various engineering organizations? And COSI, AIAA, we talked about before, the big ones here locally, the National Academy of Engineering. We just looked at their Reverse Engineering the Mind Grand Challenge. These are all engineering organizations that have a reputation to uphold. They are proposing new laws and new standards. So who's the client? Well, typically the client's another engineer, and the client's hiring engineers to get something done. The client's the Navy, and they're hiring a aerospace contractor to work on their helicopter drone. The firm then would be Northrop Grumman, who has a bunch of engineers that work on that, on a new version of the helicopter drone for the Navy. The Navy's paying their salary through Northrop Grumman. Then there's the other engineers in your firm, those that are in your group working with you, and then yourself. So how do you use this stakeholder stuff in an ethics test? Okay, so you read the test, and it becomes a question of, do you choose to obey the law down here, and it's a bad law, and it causes people to die, risk a lawsuit by disobeying a law to keep the public safe? What do you choose to do? So this is arranged in a hierarchy with yourself at the bottom. So you sacrifice yourself all the time. An engineer works from project to project. They don't work from job to job. So you just get yourself booted off a project and make a point that something's wrong in this project, the way it's set up. All right, well, I hope I've helped you understand what this word stakeholder means, both in the classroom and on ethics tests and out in the real world.